Hi, welcome to Artistic Documentation. In this tutorial, we will discuss the basic electronics problem about Ohm's law, series and parallel circuit problems, and drop-down voltage. This problem-solving lesson will be helpful for many competitive exams, like the ASVAB, Navy Officer Test, Officer Aptitude Test, etc. Let's start today's lesson. Question 1. The process of adding impurities to a pure semiconductor is called: Option A, doping. Option B, diffusion. Option C, ionization. Option D, polarization. The correct answer is A, doping. Explanation: doping is the process of intentionally adding impurities to a pure semiconductor to modify its electrical properties. This process increases the number of free charge carriers, making the semiconductor more conductive. Question 2. The energy gap of silicon at room temperature is approximately: Option A, 0.3 eV. Option B, 1.1 eV. Option C, 2.3 eV. Option D, 5.0 eV. The correct answer is B, 1.1 eV. Explanation: at room temperature the energy gap, band gap, of silicon is approximately 1.1 eV. This band gap determines its semiconducting properties, allowing controlled conduction of electricity. Question 3. In a p-n junction diode, when forward biased, the depletion layer: Option A, becomes wider. Option B, remains unchanged. Option C, becomes narrow. Option D, disappears completely. The correct answer is C, becomes narrow. Explanation: in a p-n junction diode, when forward biased, the applied voltage reduces the built-in potential barrier, allowing charge carriers to move across the junction. This reduces the width of the depletion layer, making it narrower and allowing current to flow more easily. Question 4. A Zener diode is used for: Option A, rectification. Option B, voltage regulation. Option C, amplification. Option D, oscillation. The correct answer is B, voltage regulation. Explanation: a Zener diode is specifically designed to operate in reverse breakdown mode, where it maintains a nearly constant voltage despite variations in current. This property makes it ideal for voltage regulation in power supply circuits. Question 5. The knee voltage of a silicon diode is approximately: Option A, 0.3 V. Option B, 0.7 V. Option C, 1.5 V. Option D, 2.2 V. The correct answer is B, 0.7 V. Explanation: the knee voltage of a silicon diode is approximately 0.7 V. This is the voltage at which the diode starts conducting significantly in forward bias. Question 6. Which of the following diodes emits light when forward biased? Option A, Schottky diode. Option B, Zener diode. Option C, light-emitting diode, LED. Option D, photodiode. The correct answer is C, light-emitting diode, LED. Explanation: a light-emitting diode, LED, emits light when it is forward biased. This happens because electrons and holes recombine in the active region, releasing energy in the form of photons. The color of the emitted light depends on the band gap of the semiconductor material used. Question 7. The function of the base region in a transistor is to: Option A, act as a collector of charge carriers. Option B, control the flow of majority carriers. Option C, supply majority charge carriers. Option D, store charge carriers. The correct answer is B, control the flow of majority carriers. Explanation: in a bipolar junction transistor, BJT, the base region is thin and lightly doped, allowing it to control the number of charge carriers flowing from the emitter to the collector. This makes the transistor function as an amplifier or switch. Question 8. A transistor in which the base is much thinner than the emitter and collector is called: Option A, MOSFET. Option B, JFET. Option C, bipolar junction transistor. Option D, SCR. The correct answer is C, bipolar junction transistor, BJT. In a bipolar junction transistor, BJT, the base is much thinner than the emitter and collector and is lightly doped. This design allows efficient control of current flow from the emitter to the collector, making the transistor function as an amplifier or switch. Question 9. In a transistor, the emitter is always Option A, heavily doped. Option B, lightly doped. Option C, moderately doped. Option D, undoped. The correct answer is A, heavily doped. Explanation: in a transistor, the emitter is heavily doped to inject a large number of charge carriers, electrons in an NPN transistor or holes in a PNP transistor, into the base region. This ensures efficient current flow and amplification. Thanks for watching. I hope the tutorial will be beneficiary for your next competitive exam. Goodbye. Have a nice day.